Welcome back to the deep dive. Today, wow, you've given us quite the stack of IBM AIX documentation. It looks like a really comprehensive set covering, well, everything from the OS core and device management right through to system accounting.
Yeah, it's a lot to get through, but it's good stuff, really detailed.
Definitely. Okay, let's try and unpack this huge pile together. Our mission for this deep dive, I think it's pretty ambitious, but necessary. We need to synthesize this whole landscape of AIX knowledge. We want to pull out the really essential bits so everyone gets a comprehensive but still efficient grasp of how AIX ticks, how it handles its hardware, and tracks resource use.
Exactly. Think of it as a complete tour, end to end. We're aiming for that holistic view.
Consider this your essential guide then. Let's navigate the AIX environment.
Sounds good. And you know what really jumps out with AIX is just how much control and visibility it offers. We're not just skimming the surface here, we're diving right into the heart of it.
We'll hit the startup, process juggling, that detailed accounting, how it talks to hardware, the whole 9 yards.
Absolutely. An
Right.
end-to-end picture of AIX admin.
Precisely. So let's lay some groundwork first. AIX Operating System Management Fundamentals. We're focusing on AIX 7.3 here.
Yeah.
And one of the first things you notice is the flexibility, right? How you manage it.
Totally. You've got the classic command line, of course, for direct control, but then there's SMIT.
Yes, the System Management Interface Tool, that menu-driven approach.
Right. It gives you options depending on what you prefer or what the task needs. And sort of underpinning all that is the software vital product data, the VPD.
The VPD. Okay, explain that a bit more.
Think of it like the system's detailed ID card or manifest. It's not just what software is installed, but it's kind of the system's self-awareness. It's absolutely critical for updates, making sure things go on correctly, and, spotting problems.
Gotcha. So understanding the VPD is like step one for any changes or troubleshooting.
Pretty much, yeah. It's your foundation. And speaking of changes, OS updates. Always needed, right? For features, security patches, bug fixes, the usual.
Standard stuff for any robust system.
Yep.
And AIX has tools for that.
Oh yeah, a whole suite of tools and pretty well-defined procedures to manage updates. Helps keep things current and stable.
Okay, now let's dig into how it all starts the system startup process. It's definitely more involved than just flicking a switch.
Huh. Yeah, just a bit. It's quite a sequence. First, you've got the boot image loading. That's the initial bit of software that kicks things off.
And that needs the file systems, right?
Right.
Root and ESR.
Exactly. Those are fundamental. And AIX is flexible here, too. You've got different ways to boot. Well, the standard hard disk boot, that's your everyday one. Then diskless network boot for environments where workstations boot off a server. And you can even boot from diskette, CD, DVD, usually for installs or regivery.
Right, so who's in charge at the very beginning?
Initially, it's the init command, a
Right.
really basic interpreter that lives in the RAM file system right at the start. It's like the first supervisor.
Okay.
But init quickly hands off some early setup to a script called rc.boot.
rc.boot, what's special about that?
It's clever. It adapts. It figures out how it's booting from disk, network, media, and configures just what's needed for that initial RAM environment, like setting up network interfaces for a network boot or getting the console ready for installation menus if booting from a CD.
Interesting. So it's quite dynamic.
Very. And it actually gets called more than once during startup for different phases. Eventually, there's an rc.boot stanza in the @tab file that does the final system config just as the real init process takes over fully.
Cool, so the system's up. What about bringing it down safely? You mentioned not just pulling the plug.
Definitely not. That's where shutdown comes in. It gives you a graceful exit.
Why is that so important?
Well, it lets the system close files properly, stop processes in an orderly way, basically tidy up before powering down.
Yeah.
Crucial for preventing data loss or, messing up the system.
Makes sense. And once it's running, it operates within a system environment.
Right. That's all the settings and variables that define how the system behaves. And you can customize this stuff system-wide so it affects everyone, or just for individual users to tailor their own experience, setting paths so the shell can find commands, terminal types, email notifications, things like that.
Got it. And there were a couple of specific AIX features you mentioned for management?
Yeah, quick ones. AIX usage metric SLM tags, they work with IBM's license metric tool, ILMT, for tracking software licenses accurately.
Licensing. Always fun.
Tell me about it. And then there's AIX Runtime Expert.
Yeah.
Powerful tool for managing system configuration using profiles. I'll probably touch on that again later.
Okay. And finally, system hangs. Can AIX cope with those?
It tries. It actually has mechanisms to handle hangs and can even attempt kernel recovery from certain errors, though that recovery feature is usually disabled by default, for maximum stability.
But if it does recover?
You'll see a specific message pop up on the console saying a kernel error recovery happened, and it logs the details for you to check out later.
Good to know. All right, let's shift gears to process management. So I need to see what's running. What's the command?
PSEF, that's your main one, gives you a full list of all the active processes.
And if I suspect one's stuck or causing trouble?
You can use tools like grep to filter that 6 output and find the specific process you're looking for. Pinpoint the troublemaker.
Okay, found it. Now I need to stop it.
Right. The kill command is your tool, but you need its process ID, the PID.
AID, got it.
Yeah.
And just kills it.
Well, by default, it sends a SIG-term signal. That's like a polite request. Please terminate gracefully.
Ah, polite. Does it always work?
Not always. If it ignores SIG-term, you might need to send a more forceful signal like SIG-kill, but that's usually a last resort. And critically, you need the right permissions.
Meaning?
You either need to be root, the super user, or you need to be the actual user who started that process. You can't just go around killing anyone's processes.
Security makes sense. What about those weird zombie processes you sometimes see?
Ah, zombies. Yeah, they've finished running, but their parent process hasn't acknowledged they're done yet. To get rid of a zombie, you actually have to kill the parent process.
Right, okay.
Yeah.
Now, some tasks don't need me watching them constantly. Background processes.
Yep, easy peasy. Just add an ampersand, the in symbol at the end of your command when you run it. That sends it off to run in the background, freeing up your terminal.
Handy. And can I control how much CPU time these processes get? Like, lower the priority of a big job.
Absolutely. That's what nice and re-nice are for.
Nice and re-nice. Okay.
Nice lets you start a new process with a lower priority. Kind of tells the system, be nice, don't hog the CPU. Re-nice lets you change the priority of a process that's already running.
Can anyone do this?
Anyone can lower the priority of their own processes, make them nicer, but raising the priority, making it less nice, usually needs root privileges because that affects everyone else.
Got it. What if I want something to run later? Not right now, but say tonight at 2 a.m.
That's the ACT command. You tell it the command you want to run and the time you want it to run. It puts it in a queue.
And I can see the queue.
Yeah.
Or cancel jobs.
Yeah. At queue shows you your scheduled jobs, and at noradar followed by the job number removes a job from the queue.
Is there any control over who can use that?
Oh yeah, important security point. There are control files, varad mcronat.allow and at.deny. If at.allow exists, only users listed in it can use at. If only at.deny exists, then everyone except those listed in it can use at. If neither exists, usually only root can use it.
Good control there. Okay, let's pivot again. System accounting. What's the big picture here?
System accounting in AIX is all about tracking resource usage meticulously. It keeps tabs on CPU time, memory used, disk I/O, how long users are logged in for every single process.
Why track all that?
All sorts of reasons. Capacity planning, figuring out if you need more resources, performance analysis, finding bottlenecks, and in some places, even for billing or chargeback if different departments share a machine.
So how do you make sense of all this data it collects?
AIX helps you out there. The runact command runs automatically, usually daily, and processes all that raw data.
And produces.
Formatted reports, usually ASCII files stored in VRAD-MEXIM-X, named something like ARPA-TMMDD.
What kind of reports are in there?
It's actually a bundle. You get a daily report with overall summaries, a daily usage report with more detail, daily command summary showing which commands were run, a monthly total command summary for trends, and a last login report. Lots of different views.
How does it gather the data in the first place? What methods does it use?
Several ways. Connect time accounting tracks login duration, handled by init and login. Process accounting logs what resources each process uses while it runs. Disk usage accounting, kicked off by commands like dodisk or actdisk, tracks who's using how much disk space. And there's even printer usage accounts.
So it tracks print jobs, too. Who printed what, how much?
Exactly. Pretty comprehensive.
Are there other tools besides those daily reports for more specific analysis?
Definitely. AtCon1 gives you detailed connect time and session reports. Last login is a quick way to see when users last logged in, and SAW and SAR are great for looking at overall system activity and performance metrics, both current and historical.
SAR System Activity Reporter. Yeah, that's a classic.
It really is a whole toolkit for digging into resource use.
Okay, here's a specific scenario. What if the system clock gets changed? Does that mess up the accounting logs, like the login records?
Good question. Yes, it can. The VRAD MWTMP file logs all logins and logouts. If you change the system date, the timestamps in WTM can become inaccurate or inconsistent.
Yeah, how do you fix that?
There's a specific command for it, WTM fix. It lets you adjust the timestamps in those login records to match the actual times, keeping your accounting data accurate.
Nifty. Okay, one more thing in this area. The System Resource Controller, SRC. What's that about?
Think of the SRC as a master control program for subsystems.
Subsystems being.
Individual programs, groups of processes, maybe whole applications that provide some service on the system, like, say, a database server or a web server managed as a subsystem.
And what does the SRC do for them?
Lots. It gives you a consistent way to start, stop, and check the status of all these different subsystems. It logs if they crash unexpectedly, can notify other processes if something goes wrong, helps with tracing for debugging, allows remote control, and even lets you refresh a subsystem to make it reload its configuration after you change it.
It sounds pretty central to managing services. How does it start?
It's kicked off automatically during boot by an entry at SNIT that starts the main SSE daemon.
And you interact with it using?
A set of commands: start SSA to start a subsystem, stops SRIC to stop it, LSSRC to list status, refresh to reload config, and trace on trace off for debugging traces. It really centralizes control over all those moving parts.
Very powerful. Okay, moving on. Let's talk files. Operating system files, the basics.
Right. 3 main types you run into: binary files, that's executable code the machine reads; text files, human-readable characters; and directory files.
Secretary files are a bit different, aren't they?
Yeah, they don't hold the actual data like text of binary files. They hold metadata.
Metadata.
File names, subdirectory names, and crucially, the inode number for each entry.
Ah, the inode. That's the key pointer to the actual data blocks on the disk, right?
Exactly. The directory is like the index card catalog in a library. The inode tells you where the book, the data actually is. It's what gives the file system its structure.
Makes sense. Now, finding files. If I need to locate something specific.
The find command, incredibly powerful. You can search by name, type, file, or directory, size, modification time, tons of criteria.
What if I don't know the exact capitalization?
Use the iname option for a case-insensitive search. And it handles wildcards too, pattern matching, so you can find things even if you only know part of the name or the extension. Very flexible.
Found my file, now I want to look inside.
For text files, PUG or more are your friends. They show the content one screen at a time so it doesn't just fly past.
Yet if I need line numbers.
NL command for that. Adds line numbers.
And removing columns from text.
Ln does exactly what it sounds like.
Okay. What about linking files? The LNN command.
Right. ln creates links. By default, it makes a hard link.
Which means?
Another directory entry pointing to the exact same inode, the same data on disk, like having 2 catalog cards for the same book.
And the other type? Symbolic links.
Yep, created with LNSS. A symbolic link, or symlink, is different. It's a special small file that just contains the path, the text string pointing to the original file.
More flexible then.
Often, yes. Symlinks can point across different file systems, which hard links generally can't.
Got it. You mentioned meta characters earlier.
Yeah.
Those special shell symbols.
Yeah, crucial concept. Characters like the pipe, ampersand, and asterisk and arna, the shell gives them special meanings. Unless you quote them, the shell interprets them, which is great for powerful commands but can trip you up if you're not careful.
But mastering them is key for things like piping commands together or using wildcards for multiple files.
Absolutely essential for efficient command line work.
Speaking of shells, AIX gives you choices, doesn't it?
It sure does. You've got the classic Bourne shell, also BSH or ESH for restricted, the C shell, CSH, TCH,
Okay.
and the very popular Corn shell, KITKS shell.
And the POCX, sure.
Right, PSH. That one sticks to the PSX standard, aiming for better script portability between different Unix-like systems.
When I log in, how does the shell get configured? Startup files.
Yep. First, the system-wide etc.profo file runs, setting defaults for everyone. Then it looks in your home directory for user-specific files.
Like .profile.
Exactly. .profile for Born and Corn, .cshrc for C shell, .kshrc specifically for Corn, and .exanitric if you're using AIX Windows graphical environment. That's where you customize your own setup.
Okay, let's break down some core shell concepts. Variables.
Used to store data. You can define your own or use the predefined ones the system sets up.
Predefined like?
Home for your home directory, path listing where to find commands, IFS the field separator, PS1 your main prompt, PS2 the secondary prompt, things like that. Mail check, mail path for mail.
Command aliases. Quick shortcuts.
Yeah, use the alias command. Define LA-fuls to always mean LF or something shorter for long command use often. Very handy.
Command history. Repeating commands.
Super useful. Shells remember what you typed FC in cornpusix and C shells, or just history to see the list. Then you can recall and rerun or edit commands easily.
Command substitution. Using output of one command in another.
Powerful stuff. Use back quotes or the newer syntax. It runs the command inside and substitutes its output right into the command line.
And file name substitution. Wildcards.
Right, globbing.
Right.
Using dot for one character, for 0 or more, for a specific set of characters, lets you work on many files at once, like rm.tmp.
Input-output redirection. Changing where input comes from and output goes.
Essential. Sends output to a file, overwrites, takes input from a file, appends output to a file, redirects error messages, and redirects both output and errors. We covered some of this earlier. It's fundamental.
Shell scripts. Automating tasks.
Exactly.
Yeah.
Just text files with a sequence of shell commands, make them executable with chemabod plus X.
And you usually put that hashtag Binsh or whatever at the top.
Yeah, the shebang line tells the system which shell interpreter to use to run the script. Good practice.
What about job control? Managing background processes.
C shell and cornpusix shells have good job control. We mentioned sending to background with and.jobs lists your background stop jobs. FG brings one to the foreground. Big U puts a stop job into the background. Stop pauses a job. And kill can terminate them, often using the job number like pers1.
Cornpusix shells have compound commands. What are those?
More complex structures. Pipelines, command 1, command 2, chaining commands. Lists, command 1, command 2, running sequentially. And control flow like if.then.else.fi for loops, while loops for scripting logic.
Even the older born shell had built-ins, right? Commands inside the shell itself.
Oh yeah, things like cd, echo, export to make variables available to subprocesses, tests for checking conditions, trap for handling signals, fundamental stuff.
Restricted shells.
Yeah, R-ish or BSR, they limit what commands a user can run for security in specific situations.
And the set command for shell options.
Right. You use set option name or set option flag to turn shell features on or off, like enabling vir or Emacs command line editing in Corn shell.
Corn shell editing is nice. Add functions. Reusable code blocks.
Yep. Cornpusix supports shell functions. Define a block of code, give it a name, call it like a command. Great for organizing scripts.
Arithmetic.
Let in cornpusix for doing math directly in the shell.
Coprocesses. Two-way communication.
A more advanced feature, yeah. Run a background command and pipe input to it and read output from it simultaneously.
Conditional tests.
Yeah.
Test or on.
Crucial for scripting if statements.
Eh.
If vir value is a very common pattern test and are mostly equivalent.
And quoting. Single quotes, double quotes, backslash.
Absolutely vital for controlling how the shell interprets those meta characters. Single quotes preserve the literal value of everything inside. Double quotes preserve most things but allow variable and command substitution. Backslash escapes the single next character. You need to understand these to write robust scripts or complex commands.
C shell has some specific things too, right? History substitution.
Yeah, C shell has things like don't repeat the last command, $, for the last argument, different syntax for variable substitution, often using file name abbreviations like for home, and for expanding lists like cpfile.txt, go while.
C shell expressions and operators. At, f, while.
It has its own way of doing arithmetic, using at while, and its own syntax for if, while, for each loops, swip statements. It feels a bit different from born corn.
Its own built-ins too. Alias, history, set and v.
Right, set and v and unsetn for environment variables. Different from born corn's export. Its own if, go to, while, forch, switch, breaks, evil, exec. Similar concepts, often different commands or syntax.
Okay, quite a tour of shells. Let's switch to device management. You mentioned databases. Predefined and customized.
Exactly. The predefined database is like AIX's master catalog of all device types it knows how to support. The customized database holds the specific details for the devices actually configured on your system right now.
And who manages putting devices into that customized database?
That's mainly the job of the configuration manager, CFG-MGR.
CFG-MGR. What does it do?
It runs during boot to automatically detect and configure hardware. But you can also run it manually if you add hardware while the system is running. It uses the predefined info to figure out what the device is and updates the customized database.
Can you tell it to configure just one specific thing?
Yes, you can use flags like -c and parameters like WNAME for fiber channel, SysID, Lunid to target specific devices or storage LUNs.
How does AIX actually talk to the hardware?
Through device drivers. These are specific pieces of software, kernel extensions usually,
Mhm.
designed to communicate with a particular type or model of hardware. They translate the OS requests into commands the hardware understands.
What if I need to physically remove an adapter card? Can I just pull it?
No, bad idea. You need to deconfigure it properly first using RhymeDev.
Skips involved.
Usually you need to stop any applications using it, unmount any file systems on storage access through it, and then use ARMDev to get the device into a defined state, meaning AIX knows about it but isn't actively using it. Then you can physically remove it safely. Otherwise, you risk system hangs or data corruption.
Got it. Modern storage often uses MPIO, multipath I/O.
Right. Multiple paths to the same storage for redundancy and performance. AIX handles this well.
Key settings for MPIO.
Two big ones are reserve policy, how the host reserves the device, like preventing other hosts from accessing it, and algorithm, how AIX distributes I/O across the available paths.
Algorithms like.
Common ones are failover, use one path, switch if it fails, and round robin, spread I/O across all active paths to boost throughput. Others exist too, depending on the storage.
What about SAN replication? Copying data between sites.
AIX has support for configuring that too, working with the storage system's capabilities. You use SureDev to set attributes like sanrepsfg, migrated disk, revert disk, to manage the replication setup, migration, and failback.
Finding network adapters. Command.
General LSDev works, or SMIT fast paths like SMIT LSDNet, Ethernet, SMIT LSDS DTOC, Token Ring, SMIT ALSIT-HAM, ATM.
Naming. NTX TIC-X.
Yeah, that's the convention. N0, N1 for Ethernet, TIC-ISO for Token Ring, etc. And chtakigev is the command you'd use to change attributes for network cards or almost any device.
USB Blu-ray drives. Supported.
Yes, in later AIX versions, mainly for read-only use like accessing install media.
Okay, let's dive deep into AIX Logical Storage Management, LVM, the core concepts.
It's a really flexible layer on top of physical disks. You start with physical volumes, PVs, your actual disks or LUNs,
Group them into.
volume groups,
Yeah.
VGs. A VG pulls one or more PVs into a single manageable unit of storage.
And within VGs.
You create logical volumes, LVs. These are like virtual partitions within the VG. You can make them any size you need up to the VG limit, span them across multiple PVs, mirror them. Very powerful. Then you put file systems on the LVs or use them raw.
Creating VGs, MKVG.
MKVG on the command line, or SMIT MKVG in SMIT.
Adding more disks to a VG later.
Extend VG, VG name, disk name, or SMIT extend VG. Easy to grow the storage pool.
Are there limits? Number of VGs, PVs per VG.
Yes, there are limits, and they can depend on things like whether you're using a 32-bit or 64-bit kernel and the VG type. You need to be aware of those. Usually quite high, though.
Non-quorum volume groups, what's that about?
Okay, MKLV or SMIT MKLV. You specify the VG, size, name, and other options like mirroring or scheduling policy.
Raw logical volumes. Databases sometimes use these.
Right, an LV without a file system on it. Used for things like database data files or redo logs where the application manages the space directly. You access them via special device files in dev, like dev URLV name for raw access.
Caution about the LVCB.
Ah, yes, the logical volume control block. It's metadata stored at the start of the LV. If you use a raw LV, you have to be careful not to overwrite the LVCB, maybe by telling your application to skip the first few blocks.
Can you rename LVs? Copy them.
Yep. CHLV can change attributes, including the name, though that's less common. CPLV can copy an entire LV, useful for cloning or backups.
JFS logs for VGs, needed for journaling file systems.
Yes, JFS-2 file systems need a log device within the VG. You can create one when making the VG, SMIT MKVG, or add one later, MKLV, using type JFS-log or JFS2 log.
How do I see which disks are in use? LSPV.
LSPV is great. LSPV-LPV name shows which LVs are on a specific disk. LSPV-PV name shows the physical layout.
Moving data off a disk. Migrate depth.
Exactly. Migrate this source PV destination PV moves all the logical partitions from the source disk to the destination disk within the same VG. Useful for decommissioning a disk. SMIT migrate to V works too.
GHPV. Making disks available unavailable for quorum.
Right. You can use GHPV-VA or GHPV-VR to control whether a PV participates in quorum voting for the VG.
VGDA warnings. Volume group descriptor area.
The VGDA stores the VG's configuration metadata on each PV. If you get close to the max number of PVs allowed in a VG, AIX might warn you about potential VGDA space issues.
What file system does AIX use during boot, before disks are ready?
The RAM file system, a temporary file system created entirely in memory for the very early stages.
Max VGs depends on the kernel bits. 32 versus 64?
Generally, yes. A 64-bit kernel can typically handle significantly more VGs than a 32-bit one. Used to be 255 versus 4996, might vary slightly now.
Redundancy need at least 2 adapters.
For high availability, yes. Ideally, connect storage via at least 2 separate adapters, like fiber channel HBAs, possibly in different physical drawers, with disks accessible via both. Helps with path failure and quorum.
LV scheduling policies. Parallel.
Tells the LVM how to handle writes, especially for mirrored LVs. Parallel writes to all copies simultaneously. Parallel write with sequential read optimizes for reads from one copy, affects performance.
Mirror write consistency, MWC, ensures copies are in sync.
Yes, MWC tracks writes that are in progress. If the system crashes, it ensures mirrors are made consistent during the next boot. It adds some overhead but improves integrity. You can turn it on or off.
Shrinking paging space.
SMIT chaps.
Yep, you can reduce the size of a paging space logical volume using SMIT chaps or the chaps command, but the system needs enough other paging space available.
Paging space allocation, early versus late. Early allocation reserves the full disk space for paging immediately when it's activated. Late allocation only reserves space as pages actually need to be written out. Late is more space efficient, but carries a small risk of running out if disk fills up unexpectedly.
Okay, that's a lot on LVM. Now, managing the file systems on those LVs, common commands.
Standard stuff mostly. Backup for system backups, Cephalase split copy for online JFS snapshots backups, .dd for block level copying, .df to check space, .fsseep and check repair, mkfs to create a file system, .mount and unmount.
FESC for repairs. Need to unmount first, right?
Absolutely. You can't reliably check or repair a file system while it's mounted and potentially being written to. Unmount first, unmount or SMIT unmounts, then run FESC.
What if var fills up? Common problem.
Can be. Check for huge files using find. A look in vartm for temporary cruft. Check log files like varad mwmp or the error log, vrad and razor log.
How should you clear the error log? Not CADevNull.
Definitely not cpdevnull. That breaks error logging. You need to use the proper error log management commands like airclear or utilities related to the error daemon.
Stetter file systems. Controls mounting.
Yes, that file lists all known file systems, their device, mount point, type, and options. It also dictates the order they get mounted at boot time. You can edit it carefully.
Read-only file systems.
Yeah.
CDs, DVDs, CDRFS, UDFS.
Right. AIX uses CDRFS for CDs, UDFS for DVDs. They mount read-only, and you must unmount them before ejecting the media. UDFS also has limits, can only be NFS exported read-only.
Basic directory commands, mkdir, rmdir.
Yep, mkdir makes directories, rmdir removes empty ones, mvdir moves renames them, though mv often works too. pwd shows where you are, cd changes directory, standard Unix fare.
Okay, workload manager WLM. Resource control.
Yeah, WLM is AIX's way to manage CPU, memory, and I/O resources for different applications or user groups. Pretty sophisticated.
Key concepts, classes, rules, shares.
Right. You define classes, superclasses, subclasses to group processes. Rules automatically assign processes to classes based on user, group, application name, etc. Shares give each class a relative proportion of CPU time when there's contention. Tiers provide another level of priority.
Authorizations, memory limits.
Authorizations control who can manage WLM, and vNforce lets you set limits on virtual memory usage per class.
Configuration files.
And etc.
Usually, yeah. Inside a directory named after your configuration, like at wmyconfig, you'll find files like classes, shares, rules defining the setup.
Can you change WLM settings based on time of day?
Yes, it supports time-based configurations, and you use valueOnCNTELU to load and activate a new or updated WLM configuration.
How do you figure out which processes are hogs to begin with? Topaz.
Topaz is excellent for that. Shows real-time CPU, memory, disk, network usage per process. Helps you identify what needs controlling with WLM.
Resource sets, restricting to specific CPU's memory.
Yeah, PuSets let you pin a WLM class to run only on a specific subset of processors or within certain memory regions for very fine-grained control, maybe on large systems.
Application tagging. Apps changing their own class.
Allows applications to dynamically signal WLM to change their classification based on what phase of work they're in. Requires the app to be WLM aware. Let's revisit AIX Runtime Expert, ARX, managing configuration with profiles.
Right. ARX uses XML profiles to define desired system settings. It's about centralizing and enforcing configuration standards.
Commands, rtexget, rtexset.
rtexget reads current settings based on a profile. rtexset applies settings from a profile to the system. Crucially, rtextset.su provides a way to undo the last change, a rollback feature.
rtextdiff, rtextlists.
rtextdiff compares profiles or checks the current system against a profile. rtextlist shows available profiles.
The XML structure: profile, catalog, parameter.
That's the core. Profile is the top level. Catalog groups related settings. Parameter defines one specific tunable or setting.
Inside parameter: get, set.
Get specifies the command to retrieve the current value. Set specifies the command to apply a new value. Argument provides arguments for those commands.
Seed, prereq property.
Seed helps discover instances of parameters, like multiple disks. Prereq defines conditions that must be true before setting a parameter. Property holds extra info about the parameter.
Attributes like name, value, reboot.
Yeah, lots of attributes control behavior. Name the parameter, target value, type string, numeric, apply, like immediate reboot, and reboot true flags if a reboot is needed after changing.
Discovery, prerequisites, properties.
ARX has specific XML elements for these advanced features. Discover used with seed, prerecdef and prereq for dependencies, propertydef and property for metadata.
Command line expansion.
With an
Effective by pass-in percent v1.
Yes, allows the get and set commands in the XML to be dynamic, substituting things like the parameter name, percent, values, %v1, %v2, file names, %f1, %f2, etc. at runtime. Makes profiles reusable.
Okay, user management and environment. Basic commands, WOMI.
WAMI just tells you your username. Who am I gives a bit more, like the terminal you're on and login time.
CDE login manager.
Yeah.
For graphical logins.
Right, the common desktop environment. You can configure its login screen, especially if you have multiple monitors.
Passwords, password.
Yep, password is the command for users to change their own passwords or for root to change anyone's or manage password policy.
Environment variables again. Customize in .profile.
Exactly. We talked about path, home, etc. Users typically set or modify these in their .profile or shell-specific file like .kshrc to customize their session.
File permissions. Owner, group, other, read, write, execute.
The standard Unix permissions model, 3 sets of 3 bits, read R4, write W2, execute by 1 for the user owning the file, the group associated with the file, and everyone else. Chuma changes these using numbers like 755 or symbols like U plus X do W.
What if that's not enough? Finer control needed. ACLs. AIX Access Control Lists, ACLs.
Yeah.
They let you grant or deny specific permissions, read, write, execute, to additional specific users or groups beyond just the owner and primary group. Much more granular.
How do you manage ACLs?
Accolade displays the ACL of a file. Alkit sets or modifies the ACL, usually by editing the output of Alkit and feeding it back in.
Other key user security commands? Chown, GHGRP.
Chown changes the owner. GRP changes the group. Else group lists, group info. Pregruser choosers, ARM user for creating, modifying, deleting user accounts. LSOC to lock your graphical session.
Input-output redirection one more time. Stdin, stat-out, statter. Standard input, usually keyboard. Standard output, usually screen. Standard error, also usually screen. Defaults.
And the operators. Ready-to.
Right. Redirect stredder.
The cloud drive routes.
Redirect stredder and redirect. Pipes out of one command to stredum the next.
Here are documents.
Lets you embed multi-line input for a command directly within a script, terminated by a specific keyword.
Corn POSIX coprocess facility.
We mentioned it, that advanced way to have two-way communication with a background process using AI.
AIX kernel recovery. We touched on this.
Ah.
Kernel tries to recover from errors.
Yes, can attempt recovery from certain software errors to avoid a full crash. Disabled by default, usually.
And if it works, you get a console message.
Right, a message indicating recovery happened and that details are in the error log.
Finally, AIX event infrastructure.
Yeah.
Real-time event notification.
Exactly. A framework for kernel subsystems or even user programs, producers, to notify interested user space applications, consumers, about specific events happening in real time.
Components. Kernel extension, consumers, producers.
Yep. Kernel extension does the monitoring. Consumers register interest. Producers generate event data. A kernel interface handles delivery.
How do consumers register?
They write criteria, keywords, filters to special monitor files in a specific file system, basically telling the kernel what events they care about.
Event data keywords. Begin event info, time at sec.
Yeah, standard stuff like begin event info, end event info, framing the data, high-res timestamps, time at sec, time at vinsec, a sequence enum, plus keywords specific to the producer describing the actual event.
Examples of producers, .mod file, CL disk estate.
Mod file generates events for file changes, rename, truncate, clear, overmount. CL disk state reports changes in cluster disk status like UP or DAO-N. There are others for things like network events, file system events, etc.
Wow. Okay, that really brings us to the end of an incredibly thorough journey. We've covered a massive amount of ground.
We really did. From the OS fundamentals, processes, accounting files, shells, all the way through devices, LVM, WLM, users, events, pretty much end to end.
Yeah, we definitely aim to leave no stone unturned based on that documentation. The goal was that complete, holistic view of AIX administration.
Hopefully, this exhaustive exploration gave everyone not just the facts, but a real feel for the capabilities and the intricate nature of managing AIX.
So thinking about all this, the sheer depth and configurability AIX offers, what specific areas do you or our listeners now see as most critical in your own environments? And how could these tools and concepts we discussed really help you get deeper insights or better control?
That's a great question. Or maybe thinking bigger picture. With IT getting more complex all the time, how does really understanding an OS's internal monitoring and management, like we see in AIX, give you a strategic edge for stability, performance, security?
Definitely a lot to chew on there. Well, thank you for navigating this huge amount of material with us on this deep dive.
My pleasure. It was a good run through.